Hello, my name is Alvin Chong, and our topic is Group 5 Installation of Motion Sensors at Corridors and Toilets for Unimap Laboratory and Office Building. And I will start off with the introduction. As you all know, Malaysia has strengthened its commitment to sustainable development through National Energy Transition Roadmap introduced in 2023, which emphasizes energy efficiency in public buildings. Lighting alone accounts for about 15 to 25% of energy consumption in commercial and institutional buildings. Yet many public facilities still rely on manual lighting control, leading to energy wastage. In educational buildings, the highest non-critical energy waste occurs in areas like corridors, staircases, and restrooms, where lights often remain on even when there is no occupancy. Studies shows that installing motion sensors in these areas can reduce lighting energy use by 30 to 77%. At University Malaysia Perlis, corridor lighting in laboratories and offices is currently manually controlled. This project proposes the use of motion sensor-based lighting systems to reduce unnecessary electricity consumption, especially during after hours, weekends, and semester breaks. This initiative helps lower operational costs and supports national energy efficiency and sustainability goals.
I am Lee Jun Yong, and now I will talk about the network diagram of the project. First, what is AON diagram? AON diagram refers to activity on node diagram, which is used to represent the logical sequence of activities. The purpose of AON diagram is to illustrate dependency relationships between project activities, identifies critical activities that affect project completion, and also supports effective time planning and schedule control. This is the AON diagram of our project. Each node represents an activity and arrows shows logical dependencies. The activities are arranged in a single sequence, which start from activity A until activity T. The minimum project duration is 66 days. This is the CPM scheduling results of our project. From this table, we can see that the slack of all activities are 0. This is because ESEF and LSLF of all activities are equal. Thus, the slack or float of activities are 0. Now, I will continue the topic project impact and sustainability. The first impact of the project is motion sensor installation improves energy efficiency. It also enhances safety and smart building performance while supporting sustainable campus development. This motion sensor installation project also achieves several sustainable development goals, which are SDG 7, affordable and clean energy, SDG 12, responsible consumption and production, and SDG 13, which is climate action. The SDG 7 is achieved because motion sensors reduce unnecessary lighting usage. Lighting operates only when occupancy is detected and improves overall electrical energy efficiency. For SDG 12, responsible consumption, this is because reduced lighting operation extends lamp lifespan, less maintenance and electronic waste, optimized use of electrical resources. For SDG 13, climate action, lower electricity consumption reduces carbon emissions, support climate mitigation at institution level, scalable for implementation across campus buildings.
Hi, my name is Dennis. The Gantt chart is a useful tool for me to planning, scheduling, and tracking the project. It will providing a visual timeline task for the duration and dependency. It will help the project manager to visualize their project and the timeline. By using this, we can easily to monitor the progress by comparing the plan versus complete work and manage the resource. So, Through this Gantt chart, we can know that this project is scheduled to start on a Friday, which is 2 of January 2026, and will finish on the Tuesday, which is 7 April of 2026, with a total duration time of the 66 days. The overall project budget is about 44,700. So this Gantt chart will provide a clear visual representation of this project timeline by the task sequencing, duration, and the resource allocation throughout the project lifecycle. So this project will be divided into the 6 main phases, which are arranged sequentially to ensure the smooth workflow and the minimal disruption. So in phase 1, I will classify it as a preliminaries. This phase will focus on the project initiation and the planning. It includes defining the project scope, conducting the site surveys, and preparing the detailed design drawing and finalizing the system architecture. So this phase is ensure that all the technical and the stakeholder requirements are clearly established before moving forward. So the phase 2 is about the procurement and the contract. In this phase, tender documents are prepared and issues bids are evaluated and the hardware vendors are selected. The purchase order are then issued and delivery the schedule are confirmed. By using this Gantt chart, we can know that this phase is critical to ensure all the material and equipment are available on time. The phase 3 is the pre-installation and the preparation of this project. This phase is involved about obtaining the necessary permit, setting up the sites, and mobilizing tools and the safety measure. By using this phase, we can know that pre-testing of the sensor is also conducted to ensure functionality before actual installation begins. By moving on to the phase 2, which is installation and integration, this is the core execution phase of this project. The activity includes the installation conduit and trunking by pulling and terminating the low voltage wiring, and also the most importantly with the mounting motion sensor in this corridor and the toilet. And all these sensors were connected to the building management system, which is BMS and the lightning control panel. So most of these tasks will interface are carried out by the licensed electrician and wireman by ensuring their compliance with the MS standard, which is electrical standard. So the phase 5, we can see that there is the testing and the commissioning part. Once the installation is complete, the system power up and the initial testing are conducted. This is followed by the calibration and programming of the sensor sensitivity and the time delay. The UAT, which is user acceptance testing, are walked through are performed to confirm the system to meet the operation requirement. So the last phase is the cost out and the handover phase. The final phase is include about the project cost out, preparation of final documentation, and the training for the facility staff. This is to ensure that the client can operate and maintain the system effectively after the handover. So, as shown in this Gantt chart, most activity follow a finish to start this dependency, meaning to say each task will begin only after the previous work task is complete. This structure sequencing reduces risk and ensure the quality control at each stage.
Hi, I'm Teng Wei Xiang, and I will start my presentation with project objective. So the first objective is to reduce the campus indirect greenhouse gases emission, and the second one is to integrate and commission the entire motion sensor system into the existing building management system. And the third one is to align the Unimap's laboratory and office building infrastructure with the goal of the National Energy Transition Roadmap and the guidelines of MS 1525/2019 for non-residential building. This is the physical resources required in this project. We assume one laboratory building and one office building for this project, and each has 4 corridors and 4 toilets. Each corridor needs 10 motion sensor, and each toilet needs 5 motion sensor. So the total motion sensors needed will be 120 units. This is the budget for physical resources. A motion sensor is estimated approximately 120 ringgit. So total number of 120 motion sensor will cost 14,400 ringgit. The cable connection for one motion sensor is estimated about 24 ringgit, total 2,880 ringgit. So the total cost estimation for physical resources is 17,280 ringgit. This is the human resource for this project. One electrical supervisor is needed as project manager, one licensed electrician is needed as the site supervisor, and 3 wiremen is needed for installation, wiring, and mounting tasks of the motion sensor. This is the list of activity for this project. The project starts with the preliminary, procurement and contracts, continue by the pre-installation and preparation, installation and integration, testing and commissioning, and the last step is close out and hand over to the stakeholder. These tables show the RACI model for the linear responsibility chart. R stands for responsibility, S stands for accountable, C stands for consulted, and I stands for informed. This is the project linear responsibility chart. On the top is electrical supervisor, licensed electrician, wireman, and stakeholder. And inside the table we can see it show the responsibility of each party in each task or each phase of work.
So in conclusion, this project proposes installing motion sensors in corridors and toilets at Unimap, laboratory, and office buildings to reduce energy waste from manual lighting. By using occupancy-based control, unnecessary lighting during after hours, weekends, and semester breaks can be eliminated. This installation will take 66 days from 2nd January to 7 April 2026 with an estimated cost of 44.7 thousand. Overall, this project helps Unimap save costs, reduce electricity consumption, and support Malaysia's energy efficiency goals and the Sustainable Development Goals.